Hi everyone, welcome to Dream High Hub. This is your friend and a coder just like you. Have you ever wondered how Instagram remembers your username every time you log in? Or how WhatsApp knows who sent a message? Or how Netflix remembers the movies you have watched and recommends what you might like next? Every application stores thousands, even millions of pieces of information every second. But have you ever stopped to think, how does a computer actually remembers all this data? Before a program can remember anything, programmers first need to write clean code, document it properly, and store the information in the right way. And that's exactly what you will learn in today's video. We will cover comments, docstrings, variables, identifiers, variable naming rules, keywords, and finally, one of the most interesting beginner concepts, how Python stores variables internally. By the end of this video, you will have a strong foundation that will make the rest of your Python journey much easier. So without wasting any time, let's get started. Start our first program. Let me ask you a simple question. Have you ever borrowed someone else's notebook before an exam? Imagine opening a notebook and finding page after page filled with formulas and answers, but there are no headings, no explanations, and no notes. You might still read it, but understanding it would take much longer. Imagine another notebook where every chapter has a title, important points are highlighted, and small notes explain difficult concepts. Which notebook? Obviously, the second one. Programming is exactly the same. Good comments and notes make your code easier to understand for you and for others too. When we write code, we are not only writing for ourselves or for computer, we are also writing it for other developers who may read or maintain the code in good comments and notes make your code easier to understand for you and for others too. That's why programmers leave notes inside their code. These notes are called comments. Alright, now that we understand what comments are, let's see how they actually work in Python. I'll write a very small program that prints students' total marks 1 equal to 20, marks 2 equal to 30, total equal to marks 1 plus marks 2. And let's print this total. Okay. Let's run it. The output is 50. But did you notice something? Python completely ignored the first line, the comment. It only executed the actual code. That's because comments are only for humans to understand the code, not for Python to execute it. Let me prove that Python ignores comments. Change this print of total to comment. Now let's run again. Nothing prints. What happened? We didn't delete the code. We only added hash symbol before the print of total. By adding a hash symbol, we converted the entire line into a Python. Since Python ignores comments, it ignored this line too. Now let me take another example. Print of world Python. Let's run it. We got all the three lines as output. Comment this day while testing programs. Instead of deleting the entire code or really disable it using the comments. That's a real world use case. Suppose you have like 500 lines of code. Suddenly something is not working. Instead of deleting the entire code, developers comments out the parts of the code one by one to find out where the problem is. Once debugging is complete, developers simply remove the hash symbol. That's much easier than rewriting the entire code. So comments work in Python. Comments have two main purposes. First, they help explain the code for humans. Second, they allow us to temporarily disable code while testing or debugging. They help us write clean, readable code and Python completely ignores them during execution. Great for adding short notes. But what if we want to write a detailed explanation about a function, a class, or an entire module? Can we still use comments? Yes, we can. But Python provides a much better way to document our code. These are called docstrings. Let's understand what docstrings are. Imagine you have downloaded a new mobile app. Before using it, you might open the help section or read the user guide to understand how it works. Similarly, when a developer writes functions or libraries, they also provide documentation so that other developers know what the code does and how to use it. In Python, this documentation is written using Docstrings. A docstring is a special string enclosed within triple quotes that is used to describe what a function, class, or module does. Docstrings help developers write clear, understandable, and well documented code. Let me write a function here to calculate the total marks. Colon. Let me write the documentation for this particular function. Let's take triple quotes. This function calculates the total marks, turns the result. Close those triple quotes. 1 marks 2. Let's print this function calculate total 20, 30. Let's run again. See, we got the output as 50. Text inside the triple quotes is not part of the program's logic. It's there to explain what this function does. This explanation is called a docstring. So let's understand how docstrings are different from comments. Let me get the docstrings for the. So this is where docstrings are different from the comments are mainly for developers reading the code, whereas docstrings become part of the documentation. Python can even display them automatically using the help function or the doc attribute. So remember this simple difference. We use comments to leave notes inside our code, and we use docstrings to document functions, classes, and modules so that other developers can understand how to use them. Once you know this difference, choosing between comments and docstrings becomes very easy. But let me ask you a question. Can comments store your name? Can docstrings store your age? Can they remember your marks or your salary? And the answer is no. Comments are only for explanations and docstrings are only for documentation. But every application we use today stores information like Instagram remembers your username, WhatsApp remembers your charts, Netflix remembers the movies you have watched. So how does a Python remember information? That's where variables comes into the picture. So, what is a variable? Imagine you are moving into a new house. You have three cardboard boxes. One box is labeled clothes, one box is labeled books, one box is labeled as important documents. Now think about it. Can you change what's inside the clothes box? Of course. Today it may contain t-shirts and tomorrow you can remove them and keep jackets instead. The label on the box stays the same, but the content inside it changes. Labels works exactly the same. Given to a value, you can think of it as a label box that stores the information. This label is called the variable and the information inside is called the value. Let's see this in Python. Equal to 25. What do you think happened here? 25, this is the value, and equal to, this is called the assignment operator assigns or stores the value on the right hand side into the variable on the left hand side. Let's run it. So what we got 25 as the output. So Python remembered the value because it was stored inside a variable. Take another example. Equal to Pavan. Salary equal to 50,000. Let's print name salary. Now Python is storing two completely different pieces of information. One variable stores text, the other stores the number. We will learn more about these different data types in our next tutorial. Let's write salary equal to 60,000. After hike, the salary will change, right, the next year. So let's run it. What happened? Did we create another variable? No. We used the same variable, but we changed the value stored inside it. That's exactly why it's called variable, because the value can vary or change over time. Think about your age. Today, this year it might be 25 and next year it will become 26. So when we run this, we'll get the output as 26. Did you become a different person? No, right? Only your age changed. Similarly, the variable name remains the same while the value can change. A variable has three parts. First, the variable name, second, the value, and third, the assignment operator that stores the value inside the variable. So far, we have been creating variables like name, salary, age, etc. So, what is the age here? Age is assigned and equal to is the assignment operator. Together, this formed a variable. But here is something interesting. Python has a special name for the names we give like age, name, and salary. These names are called identifiers. So, let's understand what identifiers are. Imagine you are in a classroom with 40 students. How does a teacher identify each student? By their names, right? Suppose your name might be Sita and someone else's names might be Ramu. The name doesn't contain the person, it simply identifies that person. Similarly, in Python, the name we give to a variable helps Python identifies it. That name is called an identifier. Just like a name helps a teacher identify each student, an identifier helps Python identify each value. An identifier is simply a name we use to identify a variable, function, class, or any other object in Python. In today's tutorial, we will focus on variables because that's what we have learned so far. Look at this example like age equal to 25. Age is the identifier here and 25 is the value. To age identifier equal to assignment operator and 25 value, it will become the variable name. Now we know what an identifier is. So identifier is simply the name we give to a variable. But here is an important question. Can we give any name we want? Can I write 1 to 3 age which starts with a number? Or can I write student space name which contains a space? Or maybe using special characters like at the rate, dollar sign or hyphen which contains the special characters? The answer is no. Just like every language has grammar rules, Python also has rules for naming identifiers. Let's learn them one by one. Let's start with rule number one. Use letters, numbers, and underscores. So let's write student underscore name equal to Kavita. Age equal to 26. Salary underscore 50,000. All three examples work perfectly because Python allows letters, numbers, and underscores in variable names. Although numbers are allowed, they cannot appear at the beginning. Let's see what happens. Python shows an error. So Python immediately gives us an error. Why? Because identifiers cannot start with a number. And that's exactly our rule number two. So we cannot start with a number. So if we modify age 2 equal to 26, it works perfectly. Identifiers cannot start with a number. Rule number 3, special characters are not allowed. If we write student space name equal to Monica, let's run it. Can you guess why this is failed? Because Python thinks student and name are two separate words. Instead of spaces, programmers use an underscore here. So let's run again. The underscore is the exception and it's widely used in Python. So we can rename this rule as like special characters are not allowed except underscore. And now let's move on to the rule number. Python is case sensitive. Let's see age equal to 25 and age equal to 26. Let's print both as two separate values. Did you expect the second value to replace the first one? And it didn't because Python treats uppercase and the lowercase letters differently. So here age and age are two completely different identifiers. So our rule number 4 is Python is case sensitive. Finally, let's move on to rule number 5. Keywords are not allowed or keywords cannot be used. Let's see. is equal to 10. Interesting. We followed all the previous rules. There is no space, it doesn't contain any special character, and it does not start with a number. So why did Python still gives us an error? Because if is a keyword. So imagine you have booked a movie ticket. You enter the theater and notice that few seats have a board saying reserved. Can you sit there? No, because those seats are already reserved for someone else. Python has something very, some words are already reserved by Python itself. These words already have a special meaning. They are called keywords. So keywords are reserved words in Python that have predefined meanings. Since Python already uses them for special purposes, we cannot use them as variable names. The examples of keywords are like true, false, if, else, for, why, try, def, class, etc. You cannot use these words as variable names. Whenever you create a variable, always choose a name that is not a keyword. Equal to 10, Python gave us an error because if is already reserved word reserved by Python to write decision making statements. So Python doesn't allow us to reuse it as an identifier. Also test with other keywords like for, while. So each of us gives an error. How can we check all these keywords, right? So Python also have built-in module to check what are all the keywords in our current Python version. Import keyword, print of keyword dot kw list. So using kw keyword dot kw list, we can see every reserved keyword available in our Python version. Don't worry about memorizing all these keywords today. As we continue learning Python, you will naturally start using them one by one. Okay, great. So far we have learned how to create variables, how to name them correctly, and which names we should avoid. But here is a question that few beginners ask when we write age equal to 25, where this value actually stored, 25 actually stored. Does Python really create a small box called age and put 25 in it, right? Or when we learn first time programming. And it's a great way to begin. But internally, Python does something much smarter. Remember our cardboard box example that a variable is like a labeled box that stores a value. That's a great way to start learning Python because it makes the concept simple. But now it's time to understand what's really happening behind the scenes. Now imagine your mobile phone. Let's say you have contact name saved as mom. Now think about it. Does your phone actually store your mom inside the contact? Of course not. The contact name mom simply points to your mother's phone number. The contact is just a reference. Python works in very similar way. Suppose equal to 10. When we write a equal to 10, Python creates an object with the value. A doesn't contain the value. A simply refers to that object that contains the value. Now let's another variable b equal to a. Now here is an interesting question. Did Python create another object with the value 10? Most of us think the answer is yes, but actually no. Both a and b refer to the same object. Python is smart. Instead of creating two identical objects, it simply lets two variable names refer to the same object. Let's see this in Python. 10 b equal to a. Print the memory identity number of a and b to see whether both are stored in the same memory location or not. Did you notice something? Both IDs are exactly the same. The ID function returns the memory identity of an object. Since both IDs are identical, it means both variables are referring to the same object. Don't worry too much about memory addresses right now. The important thing to remember is a variable doesn't actually store the value, it stores a reference to the object. So let's quickly recap what we have learned. At the beginning of this tutorial, we imagined variable as labeled boxes. That model helped us understand the basic idea. Now we have learned how Python actually works internally. Python creates objects in memory and variable names refers to those objects. And multiple variables can even refer to the same object. As you continue learning Python, this especially when we work with lists, dictionaries and objects. Awesome. We have covered a lot of important concepts in today's video. Let's quickly revise everything in just 1 minute. First, we learned about comments are nodes written for humans and Python ignores them during execution. Next, we learned about docstrings. Unlike comments, docstrings are used to document functions, clauses, and modules. Then we learned about variables allow us to store information like names, ages, marks, and salaries. After that, we understood identifiers or simply the name we have given to the variables. We also learned the rules for naming variables. For example, they cannot start with a number, can't contain spaces or special characters, and Python is case sensitive. Then we discussed keywords are reserved words in Python, so we cannot use them as variable names. For example, like if, else, for, while, def, written, all these are keywords. And finally, we looked behind the scenes and understood how Python stores variables internally by creating objects in memory and making variable names refer to those objects. Excellent. If you have understood all these concepts, you have built a strong foundation for learning Python. Before we finish, let's do a quick quiz to test your understanding. Answer our first question. Which one is the identifier?
3, 2, 1.
And the correct answer is age. So, age is the identifier here. One name equal to Kavita. Will this work?
3, 2, 1.
Variable names cannot start with a number. Let's move on to third question. So A equal to 10, B equal to A. Do A and B always refers to different objects?
3, 2, 1.
No. Both variables refers to the same object in this example. Let's move on to our final question. If equal to 10, can we use if as a variable name?
3, 2, 1.
No. Because if is a no. Because if is a Python keyword. If you answered all the 4 questions correctly, fantastic. You are ready for the next tutorial. Now that you know how Python stores information, the next question is what kind of information can Python actually store? Can it store numbers, text, true or false values, collection of data? And the answer is yes. In the next tutorial, we will learn about integers, floats, strings, booleans, and many more examples and practical coding. So make sure you don't miss it. Keep learning, keep practicing, and most importantly, keep coding. I'll see you in the next video.